In this video, we are going to discuss in which area that electrical engineers have to focus for the electrical wirings. Now, in case of our country, we have these are the power generation and the transmission project from the DGPC, the Do Green Power Corporation. It's the power generation is at 11 kV, and then under DGPC we have so many hydropowers. Now this 11 kV is now taken care by the Bhutan Power Corporation, the PPC. Now this PPC will take care of the power transmission sector and then the distribution sector. In the transmission sector, the voltage levels are 11 kV, and we have 33 kV, 66 kV, then 110 kV to 20 kV, 440 kV, and so on. And now this is the high voltage. We have high voltage in the transmission sector, and then when it comes to the distribution sector, again it's stepped down into the medium and the low voltage. 11 kV is a medium voltage, and then we have single phase voltage at the low voltage, 230 volt, and then we have a three phase low voltage, 440 volt. Now this transmission and distribution sector is taken care by the PPC. And then if you're planning to design for the electrical wirings, then we should be focusing in this area. The rest, the industrial buildings, the residential building, commercial building. And then for the power supply, we have option of selecting two: single phase supply, which is of 230 volt, and then three phase supply, which is of 440 volt. Our choice are limited to only this 2 volt, voltage, the low voltage. Now this is the power flow diagram that we have while doing the electrical wirings. Now from the PPC, in the distribution sector, we have low voltage 230 volt and the 440 volt for the single phase and the three phase respectively. Before connecting to the main bus bar, main distribution board, we also call it as a BB, the bus bar. Before connecting to the bus bar, we have to connect some control gates. Now control gates here is molded case circuit breaker. Now this molded case circuit breaker size, the rating of this MCCB depends upon your total connected load in that particular building. Now, MCCB is a molded case circuit breaker. Now we can also connect here ELCB, earth leakage circuit breaker. You can also connect here RCCB, residual current circuit breaker. Now this control gauge, this ELCB, RCCB, MCCB are called control gauge. Now this control gauge size depends upon your connected load. Now this the ratings are rated in the current capacity, current carrying capacity. So cable size, the size of the cable from the main line, main supply also depends in your total connected load. And then from the bus bar, we have to connect it to the SMDB. Now this bus bar, we also call it as a main distribution board. Now from the main distribution board, we are supplying it to the sub main distribution board. Now in the particular building, you can have one main bus bar, and then for each floor, you can have number of SMDB, the sub main distribution board. Now to connect the energy meter, you can either connect if that building is occupied by the single family, then you can connect that the energy meter here. But if it has a multiple occupants, then you can give the different energy meter here. So for SMDB1, we can give the different energy meter. For SMDB2, again different energy meter. And then from in the SMDB, we can see the MCB, the manager circuit breaker. Now this is the difference between MCCB and MCB is this is of higher capacity, the current carrying capacity, and this one, the maximum current carrying capacity will be 100 ampere. For here, it can go in thousands. For MCCB, the commonly used the current carrying capacity is 6 ampere and 16 ampere. Now we can also use 10 ampere as well, depending upon the availability in the market. So the 16 ampere MCB is used for the power points. Now in this power point, we are using the refrigerator, then air conditioners, then curry cookers, rice cookers. For this one, you can use the 16 ampere MCB. And then for the lighting and the fan points, you can use the 6 ampere MCCB. Or that is not like that. One light point and one fan point will have one 6 ampere MCB. It's not like that. This 6 ampere MCB can carry 800 watt load, and for 16 ampere MCB it can carry 2000 watt load. So depending upon this one, you have to connect this control gauge. Now the size of the wire for the power point, we are using 4 square mm, the size of the wire. And from the sub main distribution board to the switch box, we are using 2.5 mm square wire. And then from switch box to individual light points, we're not talking about the looping and all, okay? From switch box to light points and the fan points, we are using 1.5 mm square. Now, if you again calculate the size of the wire depending upon the rating of the fan and the light points, it will come smaller than this. Why we are using the bigger size of the wire? Now, this one is simply for the safety point of view. For the safety point of view, we are using the bigger size of the wire. Now, for here also, the size of the wire will be smaller, but in the actual practice, we are using 4 mm square for this from the safety point of view. And then, okay, electrical. Okay, now let's see in the engineer ways, like for the civil and architecture drawing, they will just give the purpose of the drawing, the structural aspect, and the aesthetic aspect. And then electrical drawing, we have to see the correlation details, the legends and symbols, load analysis. These are the type of work that electrical engineers do. From the electrical drawing aspect, we have to see again the electricalized items, estimation and the cost analysis, list of the items and rate as specified in the vehicle. Now, if we're doing for the tendering documents and all, we have to take care of the estimation and the cost analysis. And then also we have to do the cost analysis depending based on the bill of quantities. But if you're doing for the private drawing and all, you don't have to do for the bill of quantities. We just have to give the drawing. And then, okay, now these are the examples of the electrical load. For example, if you're using the incandescent lamp, it will be 100 watt or 60 watt. Now, because of the involvement of the LED, now this bulb are going extinct now. We're no more using these bulbs. And then we have fan 60 watt, 16 ampere power socket. We consider it as 2000 watts. Because this power socket, the connected load may be less than this. Now, highest load that we have is the AC. The currently used in our country is like 2 ton, 1.5 ton, 1.7, and 5 ton, like that. The maximum that we're using is 2000 watts. So this 2000 watt can be connected to the 16 ampere power socket. And then we have 6 ampere socket. So this 6 ampere socket is 100 watt. Now this one is this one comes along with the switch box. And then again we have fluorescent lamp of different rating, exhaust fan, and then we have mirror light. Okay, the 6 ampere socket, we can go up to 800 watt. You can write 100 watt to 800 watt in this case. And we also have the mirror lights and all. So we can also now to do the analysis and all, we have to know the connected load. The total connected load is calculated based upon the determined number of lighting and the power points. Now, whether you are using the uh, electricity or not, if you have given 5 number of socket, then we have to consider that one as a connected load, and then we have to include that one in your calculation. Also, we have to use the diversity factor. The DF is applied to determine the connected load. Now, once we have determined all the connected load in your building, then we have to apply the diversity factor. Now, usually we are applying the diversity factor as 0.6 to 0.8. But best, I think in the standard, it should be 0.5 or 0.6. And then connected load determines the type of power supply. See now, as I said, if the connected load is more than 12 kilowatt, then we have to give three-phase supply. If it's less than 12 kilowatt, we have to give single-phase supply. When connected load of the building exists more than 12 kilowatt, three-phase power supply is provided. Okay. The current ratings are determined for the whole connected load and connected load at individual sub-circuit. Now, whole circuit means starting from that the main VPC supply, and then for the sub-circuit, it comes from the sub-main distribution board. Now, how to calculate the current? Total connected load divided by, in case if you're using the three-phase supply, so we have to use 440 times 0.8. Now, this is the power factor that we are assuming. You can use that 0.8 or 0.9. We cannot go for 1. Actually, if your power quality is good, then you can have that power factor as 1, but we cannot achieve that 1. So we can take 0.8 or 0.9 times root 3. Now this is the standard formula that we have to calculate the current. And then for the single phase supply, we have again 230 times 0.8. So this connected load divided by this. And then current ratings, okay, as I said, depending upon the connected load, your cable size can be determined from the current rating, the connected load, and then also the other control gates like MCB, MCCB, RCCB, ELCB, all depends upon the connected load. We cannot use same MCB, MCCB, RCCB for all designs. Depending upon the building size and the load size, it will depend. And then, okay, in the next video, we're going to discuss about the planning of the electrical wiring for the buildings.